Okay, so this is the warm-up for your first quiz over the periodic table. So first you're going to have to fill out this chart and then answer some questions. All right, so first you have to identify where beryllium is. And so beryllium is right here on the periodic table, which is in the second column. The second column is called the alkaline earth metals. Because it's in the second column, it has 2 valence electrons. And if you remember from before, our 2 valence electrons, we're going to lose 2 electrons. So if we lose 2 minuses, we become a positive 2 charge. That's a cation. And when we lose electrons, we become smaller. Okay, bromine is on the other side, which is right here, which is in the 7th column. 7th column, it has a family name called the halogens. Halogens are in the 7th column, so it has 7 valence electrons. In order to become a noble gas, it's going to gain 1 electron. When we gain 1 electron, we have 1 more negative than positive. That's an anion. When we gain electrons, we become larger. Next, rubidium. Rubidium is over here, which is in the first column. The first column is then called the alkali metals. First column means it has 1 valence electrons. When you have 1 valence electron, you're going to lose that one, so you become a noble gas status. When you lose a negative, you become positive. That is called a cation. Losing electrons make you become smaller. All right, helium is over here in the 8th column, which means that it is a noble gas. Remember, helium is a weird one, so instead of writing 8, it has only 2 valence electrons, but it's still a noble gas. Because it's a noble gas, none of these boxes apply. Okay, so now let's fill in the rest of the questions here. Okay, Dmitri Mendeleev is commonly credited as being the father of the periodic table. How did Moseley and Mendeleev arrange the periodic table? Which one is used today? All right, so Moseley arranged it by atomic number, which are protons, and Mendeleev did it by atomic mass. Remember, both used chemical properties to put them in columns. Now, which one do we use today? Today, it's arranged by your number of protons. Therefore, Moseley's is a periodic table we use today. All right, cations, remember the T have a positive charge, okay? And when we have cations, why did it become a positive charge? Because we lost electrons. That means we become smaller than the atoms from which they were formed. All right, it says how many electrons will nitrogen gain or lose and why? Okay, so here's a different element. So if we look at the periodic table over here, nitrogen has 5 valence electrons. Okay, so if nitrogen has 1, 2, 3, 4, 5 valence electrons, right? The question is, how can it look like a noble gas? He has 2 options. We could either lose those 5, or we could gain how many? 3. Now, which one seems easier? Definitely this one over here. Gaining 3 is a lot easier. Well, that didn't work out. So gaining 3 is a lot easier than losing 5. So when we gain 3 minuses, okay, then what kind of charge do we have? Okay, So if we counted up all our pluses and minuses, we will have 3 more negatives than positives because we gained 3 electrons here. When we gain 3 electrons, it becomes larger. All right, so name one element that is a metal and one element that is a nonmetal. Well, all your metals are on the left-hand side of your staircase. All your nonmetals are on the right-hand side. So if you look at your periodic table, you have your staircase right here. So over here are your metals, and here you have your nonmetals. Remember that hydrogen is a nonmetal, so don't put hydrogen as part of your metals. So if you name any of those, you're good to go. Column contains your noble gases. That would be the 8th column. Alkali metals are in our 1st column. Alkaline earth is in our 2nd column, and halogens are in our 7th. Make sure you know which column goes with which family.